Good morning, 8th graders. I wanted to make a short video to go over some examples of the work that you'll be doing today. So as you guys know, we spent last week going over a few lessons in Chapter 7. We did not do the whole chapter because the whole thing was review for you guys, and I didn't want to stay on those topics that you've been doing for a couple years now for too long. So this is the chapter quiz, which will review all of the topics, not all of which, again, we went over explicitly, but all of which you have been taught in the last few years. So the top of the quiz, and this is a PDF that I'm attaching to your Google Classroom materials for today. If you would rather use your book, you'll find this on page 189. I've also attached the chapter summary, which you can find on 188 in your textbook, but it just goes over briefly some of the definitions that we did in our Chapter 7 vocabulary, and just some tidbits of information that you can use to help you solve these problems up here. So again, since I am using the PDF on my computer, I'm going to use my handy-dandy web paint here to annotate my screen. So first I'm being asked to write a fraction for the shaded part. So I know if I'm writing a fraction that the denominator is going to tell me how many pieces there are, and the numerator is going to tell me how many pieces are shaded. So the denominator, how many pieces in total, here would be 1, 2, 3, 4. So there'd be 4 pieces in total, right? And then how many are shaded? What's my numerator going to be? 1, 2 pieces are shaded. So this would be 2 over 4. Now, if I wanted to go above and beyond and write this fraction in lowest terms, I would look for the GCF of 2 and 4. So what's the greatest common factor of 2 and 4? It's 2 itself. 2 times 1 is 2. 2 times 2 is 4. So now I'm going to divide by the GCF, the numerator and the denominator. So the numerator divided by 2 is going to be 1, and the denominator divided by 2 is going to be 2. So 2/4 in lowest terms is 1 over 2, which equals 1/2. So you're just going to repeat that procedure for these next two problems. How many pieces in total gives you your denominator. How many pieces are shaded gives you your numerator. Okay, and whether or not you want to reduce that fraction to lowest terms is up to you. As a general rule in math, you usually do reduce fractions and answers to lowest terms. So I guess it's a good habit to get into. If you're probably already in that habit. I know your teachers in the past years have probably hammered that into you too. All right, so now we're looking to write a fraction and a whole number or a mixed number for the shaded strips. And so now we're looking at pieces that are shaded that are representing more than one whole. So what we're being given here is each of these bars, 1, 2, 3, 4, 5 bars, each represents one whole. And what I can see is that 4 of them are completely shaded in, and one of them has 3 pieces and only 2 are shaded in. So this would be 1, 2, 3, 4 holes, and then 2/3 of this final piece here are shaded. So there's not 5 holes shaded in because you're missing this one piece. So it says write a fraction and a whole number or a mixed number for the shaded strip. So I think what they're saying here is write a fraction, write an improper fraction, right? So if each of these bars is shaded into thirds, or excuse me, divided into thirds, so this is 3/3, 6/3, 9/3, 12/3, 13, 14/3. So as an improper fraction, this would be 14/3, but as a mixed number, it would be 1, 2, 3, 4, and 2/3, right? So they're looking for you to write this 2 ways. This one is a little bit simpler because all the pieces are shaded. So I'm not going to give too much away there, but just notice here that see here how there's a white space? Notice here on number 5, there's no white space. Okay, so numbers 6 through 6, 7, 8, 9 ask you to write a whole number or a mixed number for each fraction. So what you'll notice about all of these fractions is that the numerator is either greater than or equal to the denominator, which makes all of these improper fractions, if you remember from your definitions of the vocabulary. So 4 over 3, right? 4/3 is more than 3/3, so it's more than 1. So it's 1/3 greater than 3/3. So I'm going to say how many thirds do I have to take out of here to make a whole? So if I have 1, that means I took 3/3 out because 3/3 equals 1 whole. If I take 3/3 away from 4/3, what do I have left? I have 1/3 left over. So I'm going to take 3/3 out of this 4/3, I'm going to have 1 and 1/3. So that's going to be my mixed number. Okay, so a mixed number includes a whole number and a fraction. When it says write a whole number, that's just a whole number. And I'll give you a hint. There is one of these, either 7, 8, or 9, that the answer is not a mixed number, it is just a whole number. And I'm sure you can tell by looking at these which one represents the whole, which one is the numerator equal to the denominator, which is how we identify one whole. Okay. Now let's take a look down here. So multiply each numerator and denominator by 2 to find an equivalent fraction. So just writing equivalent fractions. So you guys know, and you've probably been, had this hammered into your brain from like the 6th grade, is that whenever we make an equivalent fraction, we must multiply the numerator and the denominator by the same thing. Okay, so if we're writing an equivalent fraction for 1/6, we're being told multiply each numerator and denominator by 2. So we're going to carefully read the directions. By 2 to find an equivalent fraction. So 1 times 2 is 2, right? And 6 times 2 is 12. So what this is saying is that 1/6 is equivalent to 2/12. Okay, and I'm going to draw a really, I'm going to try and make it quick, but I'm not super great with these drawing tools yet. So I'm going to try and show you guys. Oh, it's a little bit confusing that that goes in the middle. Let's do it this way. Okay. So 1/6. What does 1/6 look like? So if I first divide my rectangle into thirds, and my thirds aren't perfect, but they're supposed to be even, and then I divide each third into 6. So I'm dividing each third in half. So now, I think you guys can agree with me here that we have 1, 2, 3, 4, 5, 6 pieces in total now. And we're going to shade, let's see, we'll shade 2, one of those pieces. Because we're looking at 1/6. So I'm going to shade 1/6, which means there are 6 total pieces, and one of them is shaded. Okay, so by the logic of my equivalent fraction that I've just written by multiplying the numerator and the denominator both by 2, so I said 1/6 equals 2/12. Okay, well if that's true, when I have 12ths, if I cut all these pieces in half to make 12ths, okay, well 2/12 should be equivalent to what used to be 1/6. Is that true? So this bar used to be 1/6 when there was only 6 pieces. Now I've cut all the pieces in half to make 12 pieces. 12 of those, or excuse me, 2 of those are shaded to equal 2/12. So does 1/6 equal 2/12? Did we just represent that visually? We did. And that's all that we're doing. I could again say, I could multiply this by 2 again and say 4/24 is equivalent to 1/6, right? And if I did 4/24, I would cut this in half again. I could keep cutting it forever and multiplying by 2, and it would stay equivalent. So if someone asks you, do you want 1/6 of the pizza or 2/12 of the pizza, right? It's the same amount. All right, so you're going to go ahead and repeat that process for the rest of these to produce equivalent fractions. Numbers 14 through 17 are a little bit more difficult. You're actually being asked to write each fraction in lowest terms, which means, again, we're looking for the GCF of the numerator and the denominator, and then we're dividing by that GCF. Okay, so the GCF of 8 and 16 is 8, so I'm going to divide 8 by 8 equals 1, 16 by 8 equals 2, so this fraction is going to be equivalent to 1/2. And some of these fractions you guys will start to recognize. So you'll recognize, oh, 8 is half of 16, right? So 8/16 equals 1/2. And if you just start to recognize those, these are benchmark fractions. So if you just start to recognize those and you want to write them kind of from your memory bank, that's fine. The same way that you guys know, certain multiplication facts, you're going to start to see certain equivalent fractions, and you're just going to know what they are. All right, so you're going to repeat that process and look for the GCF in all of these numerators and denominators, and then divide by that number. Okay, here we're looking for a fraction or a mixed number for each decimal. You guys practiced doing this last week, so fraction or a mixed number. All of these can be taken out to the tenths or hundredths place. So all of these can be represented as a mixed number or a fraction over 10 or 100. Okay, so 12 hundredths is just going to be 12 over, oh, it's not a very pretty 12, I'm sorry, 12 over 100, right? 12 hundredths equals 12 over 100. When we have a mixed number like this, we just keep the whole number nice and big, and then 7 and 3 tenths. How many tenths are in 3 tenths? There's 3 tenths, right? So 7 and 3 tenths. So that's nice and simple. All right, so find the average. This is where we're adding all of these numbers together and then dividing by the number of numbers. So we're going to go the sum. So this is the letter, I attempted to write sigma. Maybe I'll use straight lines. It won't be as hard to read. So this is the Greek letter sigma, and it stands for sum. So sum of the numbers. So this is the sum of the numbers divided by the number of numbers. You guys are so patient with me while I'm trying to write on my computer. All right, so the sum of the numbers divided by the number of numbers, or the sum of the terms divided by the number of terms. All right, so hopefully this was helpful in walking you through an example from each of these sections. If you guys have questions, really the best thing to do is to take a screenshot of the question and the work that you attempted to do. So I always want you to give these a try, even if you feel like you're not sure. I want you to try, and I want you to send me a screenshot of the question and your work so that we can go over it in our live class. Because that's really the best use, I think, of our live class is to go over questions that we already have tried and we have specific concerns about. So that way we're not just talking about things that everyone understands, we're talking about the things that people really need help with, because we have such a limited amount of live time. All right, so please, again, shoot me emails with questions. Please take screenshots of your work and shoot me emails of those so we can talk about the things that we need to work on tomorrow in our live class. All right, so don't forget the second page here also has some tips for solving problems. And there's resources also from last week in your Google Classroom. There are some videos that are attached to your assignments from last week that will be helpful for this too. All right, I will talk to you guys soon.